database. Myself, Dr.Maryposonia, Department of Computer Science and Engineering. So today the entire topic we are going to cover about object-oriented data model and object. That means we have to describe the object-oriented data model with the support of object-oriented programming concepts and also your relational data model. So both the concepts we are going to discuss together, and how we are going to incorporate this object-oriented programming concepts into your relational data model, that we will discuss, and followed by how to write the schema definition by using the ODMG definition language. That is called as a, generally we used to call it as a DDL commands, but here we are going to call it as a ODMG or ODL language. That is schema definition that we will discuss, and followed by the manipulation language, how we can describe the manipulation commands by using the ODMG model. Now when coming to the object-oriented data model, look at this diagram. In this, we have object-oriented programming concepts. It is going to combine in your relational database. Say for example, in your relational database, if you are the major concepts we have to cover with the integrity, that is the consistency among your data transactions, as well as the concurrency and also query processing. So this concurrency is many number of transactions you can able to execute at a time. And also the query processing as well as the query optimization is common for all your database model. Okay, so this database concepts, the major database concepts, is going to combine with your object-oriented programming concept. So already you all familiar with the object-oriented programming concepts like Java as well as C++. So people, you should know the object-oriented major concepts. We have to know about the polymorphism as well as inheritance and also encapsulation. So the polymorphism, so we will recollect one or 2 points about the polymorphism, inheritance as well as encapsulation. So all these concepts are the major concepts played in object-oriented programming. So the polymorphism is more than the same functions or the same method can be used for the different purposes. So the values will be different, but the same functions can be used for the different purposes. And coming to the inheritance concept, so the inheritance is reusability of the code. Okay, so the certain property can be used by more than one object. So that can be what's that kind of properties as well as methods that can be written only once, and that can be reused by more than one class. So that reusability property, we are going to use it in your object-oriented database system. And also the encapsulation. So the encapsulation is nothing but your binding of data as well as the methods, okay, together as a class. Okay, so that concept is also we are going to add with your relational database. So all together, we are going to combine the concept of relational database as well as your object-oriented database. And coming to your need for the complex data, why we want to go for your object-oriented database. That is very important. Before going into any topic, we should know about why we are learning to, what is the need of we are learning this topic. See, for example, if we have a relational data model, as you already very familiar about your relational database management system. So in the relational data model, you can able to handle only the simple data types. Okay, so the simple and atomic data type. And suppose for example, say for example here, suppose for example here we are having the address. Okay, so when you specify this kind of complex database, okay, a complex data type. So address in the sense, the address is composed of maybe the street, a door number, street and city, as well as the code. So we do have some different columns. So when you have the relational data model, all these columns we have to specify separately. Then only it will be act as a atomic values. Otherwise, it will produce an error. But we need to, if you are having the object-oriented model, we can able to handle this address as a single column by using, we have a one of the data type we are going to use, it is called as a structure. By using the struct object, we can able to handle this address as a only one attribute. No need to segregate as a different columns. As like entire complex data type, we can have just a one column. That is also one of the need. And another one thing is, say for example, if it is a multi-valued attribute. So what is multi-valued attribute? The attribute will have more than one value. Say for example, if you consider the example phone number of a particular person. So the phone number, the person may have more than one phone number. So if you are representing this particular data in your relational model, you have to give the two different column. Okay, so two different column like phone number 1 and phone number 2. But we cannot able to have this multi-valued in your database data tables. Okay, but if you are using the object-oriented data model, we do have one of the data type is called as a enum. Like how we are using in your programming concept, enum is one of the data type which we are going to use it in your object-oriented database system. So in this object-oriented database system, if you are specifying the phone number as a enum type, you can have any number of phone number. So that will be act as the only one column enum data type in your database table. And one more important thing is, say, if you said like inheritance property, which we are using in your object-oriented programming concept, and that inheritance property, if we are going to use it in your relational database. Okay, so that means, say for example, when you take up a CAD application, okay, so in the CAD application, we are having the electronic circuit. Okay, so the electronic circuit, we do have the different component. Okay, so the different component, but all these components, certain functions or the certain attributes will be shared by all the components. So if you say the electronic or electric circuit, what are the common components or the common attribute? Maybe the conductor value, resistance value, or it is a ammeter value. Okay, so the watts, how much power it is consuming. So all these attributes are common for all the components. So what will happen if you are calculating the power consumption of each and every component? Then you have to use all these property. Every component should all use all these property: conductor value, resistance value, power value. So if you are using a normal relational model, so what will happen? So it is very difficult that every method, every component separately, they used to have all the attribute again and again in their methods. But if you are using object-oriented model, we can use the inheritance property, code reusability. So what we will do, whatever the properties which are common for all the component, say conductor value, resistance value, as well as the power value, how much power it is consuming. So all these attributes, they will keep as a common attribute that can be shared by all the electronic component. So when you call the method calculate power consumption. So if you execute that power consumption, each and every component will access the common property which is held in one place. So that is a use of the inheritance property, reusability of an attribute, reusability of your code, that we are going to apply in a object-oriented data model. Yes, now move on to the next one, is called as how we are going to build the object-oriented data model. So in this object-oriented data model, how you are going to how you are going to represent object in terms of ER model, in terms of relational database. relational database. Say for example, if you are having the object, so every object that can be correspond to the respective entity in your ER model, entity relationship model. Okay, so whatever object you have, every object will be represented as a entity in your entity relationship model. Okay, so we are correlating your object model as well as your relational model. Then later that we will combine both. Now, as already people, you are very well aware about your object model, what are the content available in your object, everything you are very well known all these topics. Now we will refresh them. See here, when you say this object, the object is composed of three main components. One is called as a variable. So the variable is nothing but the data in your object. Okay, so when you take up the object, see for this example in this diagram, see if you have a car is one of the object. So car have the the number of seats as well as the brake, lever. So these and all the attributes of the car. And now the start, move, stop, these and all the methods are the implementation present in your object. Okay, so when you specify any object, the object is composed of the three important components as variable, messages, as well as the methods. So the variable is nothing but the data present in your object. The data is nothing but how you represent, correlate with your ER model. So the data is nothing but attribute of your ER model. In the object, we are representing it as a data, but in your ER model, this is represented as an attribute. And the same way, coming to the methods. In your methods, say for example, if you want to implement, okay, so the car want to run or stop, or the person want to walk or dance, we have to do some actions. So the action is nothing but or implementation is nothing but a method. Right? So now the implementation is nothing but a method. So we can say that it is the body of the code implementation. Now, one object want to communicate with the other object that can be represented by the messages. Okay, so the communication between the object. One object should be communicate with the other object. Then only every object can able to access the properties and can able to execute the methods. So these are the major components present in your object. Now, so take up our ER diagram example, say in your banking database. Excuse me. So in a banking database, we are having, as usual, as we said, here what is object? We are a lot of objects are there. We have employee, customer, bank teller, all are represented as object. As I already told, every object is nothing but an entity in your ER diagram. So object is, say for example, employee is an object. Employee is also an entity in your objects. And same way, if you take up a variable, so the variable is nothing but data present in your object. So the data is nothing but attribute of your ER diagram. So the attribute is nothing but address of the particular employee is called as an attribute. And another third component is called as a messages. Messages I already told. If you want to execute the implementation, we want some methods. We want some code. So that implementation, we used to call it as a get address, set address. Here we given some example. As per our process, we can able to write our own messages. Okay. So now coming to the class. Okay, so object class. So hope you understood the object concepts clearly. So the object is nothing but every entity present in your ER diagram is called as an object. So when you relate with the entity, so the entity is having the collection of attribute. So that collection of attribute is also called as a data present in your object. Hope you understood about the object and which is related to your entity in your ER model. Now coming to the class. Okay, so here the class, we said the class is nothing but here the class is nothing but it is an entity set. Okay, so the entity set in the sense of, say for example, if you are taking a banking database, we have a customer, we have a banker, we have a bank, and we have a teller, like that. So many entities are there. All entities together, we used to call it as a bank database. Yes or no? So collection of more than one entity is called as an entity set. The same way, if you're correlating with the object-oriented concept, in object-oriented concept, what we will say, more than one similar object together, we formulate a class. Got it? That means the class is nothing but collection of similar object. So it is correlated with the ER diagram. So the collection of similar object is called as a class. So of course, more than one entity is called as a entity set. As you said, the collection of object is a class. Here, the collection of entity is called as a entity set. Right? So in that way, you have to correlate with your object model as well as, that means your object-oriented programming paradigm with your entity relationship model. And now for this, we have taken up an example. Say, for example, if you are taking a bank database again, taking a bank database, in that, here we are having the classes. What are the classes? Employee is one class, customer is one class, and loan is one class. Yes or no? So here, every class, already said, every class is an entity set. Correct? Every class is an entity set. In that way, you have to correlate your object model into your entity relationship model. Now, as like the same way how we are defining the object-oriented programming paradigm, here we do have some structural specification for representing your class. Here, this is the entire structural representation. Now, as usual, you have to define. Here there are two ways we can define your object-oriented database model. Either you can use the class definition, otherwise you can go for your interface model that you already learned in the Java object-oriented programming. So either you can define all your attributes as well as methods by using the class components. Otherwise, you can use the interface method also. So you can follow any one method. Okay, I will explain. I'll try to give both these ideas together. Then you can choose your own, which one is better for you. So now, in this class definition, the class is the employee. It is also called as an entity I told. Okay, so the entity set. Now, inside this employee class, the data members are the name as well as address and start date and salary. Okay, so these are the data member, and these are all the member function. Okay, so we need to calculate your annual salary, get name, get address, and set address, as well as employment for finding the employment length, and end it with a semicolon. Okay, so this is a normal class definition, how we do in your object-oriented programming concept, right? So here we do have all these are, here we declared all these here. The data methods are declared here. Okay, so here how many methods here? All these are data members, and these two are only member function, right? So these two member functions we declared only inside the class. So if you want to implement the method, we have to write the separate code outside the class. Okay, so outside the class, we are executing or implementing these two methods, that is get address, as well as after performing it is return the address also, and set address. It do have some parameters, and the new address can be read from the user and stored back into the variable address. And the employment length. Okay, so the employment length in the sense the period of his employee. Period of this particular employer. So when he joined and to this current date. Okay, so that can be represented and that will be written. So it is a normal, some sample example being done here. In that way, you have to define the class and declare all your data member and declare all your member functions and define your member function also. So now, coming to the code reusability, the another important concept is, so now the class definitions you clearly understood, right? So combinations of your data as well as member function. Now moving on to your reusability property. How you are going to use the reusability property in inheritance. Okay. So look at this scenario. In this, we are having a hierarchy. So in this, the person, we used to call it as a superclass. Okay, so the person is having its own attribute also, name, age, as address, like that. It is having his own attribute, and here we are treating this person as a superclass. Okay, so person is a superclass or specialization class. We can say that. There are two different terminologies are presented in your books. Okay, so all the terminologies are same. Specialized class or also it is called as a superclass. Okay, now the person is a what's that parent class of your student as well as teacher. Right? So all the properties of the person class can be used in your student class as well as the teacher. Yes or no? So say for example, the person is having the attribute name and age. So these two attributes is common for student as well as teacher. Yes or no? So using this inheritance property, the student as well as teacher subclasses can able to access the properties of your person class name and age. Okay, so no need to redefine your name here and no need to redefine age and name of the teacher here. So the reduce of your code, okay, to reduce the code, reusability of a property, the existing property present in your parent class. That is the use of reusability that you already very well know in your object-oriented programming concept. So there's the same thing. Here you are seeing, you know, class hierarchy. So the class hierarchy, the person is a root node or the person is a, here the person is a superclass. And from this person class, we do have two different objects is called as the employee as well as the customer. And from this employee, we can have the further subclasses also that is called as the officer, teller and secretary. So now all these employee and the customer can have the privilege to access all the attributes and methods of your person class. So this inheritance, okay, so this inheritance, how you are going to represent in your structured way, in your object-oriented database model for representing this class definition. So now you are specifying the class person. Class person is a specialization class. We can say that it is a specialization class also. Now you can define the class person, and under the class person, we are having two data members. One is a name and another one is the address. In certain books, it may be preceded with the attribute. Okay, so both are correct only. So the certain books, it is represented as address string, attribute string name, attribute string address. Okay, so both are correct. That means under the person class, these two are data. So the data is also called as attribute in your ER model, correct? So the name and address are the attribute of your person class. Right? And same way, now from the person class, look at the previous diagram. For this only, we have written the code here. And now from this person class, you are going to define the customer class. That is what we are writing here. Specialization class is called as a derived class. So class customer is a subclass of your person class. The meaning is as we can say that is a relationship represent the person is a subclass of your the customer is a subclass of your person class. That is a representation is by using the keyword is called as a is. Now this customer is also have its own attribute. This attribute is called as a credit rating. And once this definition is done, again define the next class is called as the employee. Employee is also a subclass of the person. So again use the keyword is a person. Again, these two are the attributes of the employee class. Okay, similar way, you have to specify the officer class. So now, hope you understood, this officer class is derived from your employee. Okay, so how you represent it? Class officer is employee. That is a representation of your defining the new class. So now, so once you define all these entities, this is also called as a entities, and in terms of object-oriented programming language, we used to call it as the classes. Yes. Now the identity of the object. Okay. So how, because since it is object-oriented database, we need to take up more terminologies about the object. What are the object terminologies are presented here? So here we do have object. Object can be identified. Okay, identified by using the three parameters. One is called as a value and name, and also the built-in. So the value is nothing but the data value. Okay, so say for example, if you want to recognize the particular tuple in your relational database, so we need a primary key. So generally we want to fix the primary key for a name column, because more than one person have a duplicate name, more than one person have the same name. So generally we have to fix the key value. Yes or no? Generally we have to fix the key value, or your roll number, your register number should be a key value that will identify an individual student uniquely, right? So the identity can be represented in terms of your key value. So that is a one. And the second thing is name. So the name is nothing but the user defined variable name. Say for example, if you're giving the key value, social security number of an employee, SSN, or register number, these are the names defined by the user. So this is supplied by the user. And apart from that, we do have some built-in functions also, or built-in names also, which will be applied for your object. So we here in object-oriented database, we have a persistent object is there. So that is a built-in object that we are going to see in the upcoming topic. So another one small terminology is called as object containment. So the object containment, it is called as is a part of. Very important thing is part of. That means one object. Okay, so the one object contains the another object. That is called as a composite object. We can say that. So the example I've given here. So the wheel is also represented one object, and under that wheel we have rim, spoke. So under that wheel, we have a rim, spoke, as well as tire. So these are the different objects. Okay, so these are the different objects present in your wheel. So wheel is a major one. It is composed of again different objects together. So the that is composite object is called as object containment. So when you are representing these relationship, we have to use a keyword is called as is part of. Okay, so previously we written as is a relationship for representing your inheritance property, and if you are representing the composite object, then you must represent the keyword is called as the is a part of. So when you go with an example, you can clearly understand this. Yes. So these are some procedural, some program aspects like intra procedure. These are very well known about you. Intra procedure in the sense your identity of the objects are the persistence only within the procedure, within the function is called as a intra procedure. And intra program is nothing but your identity of your object persists throughout the program. Okay, so only within the program or within the query. And when you come to the inter program, so the inter program is nothing but only within the program the other program can able to communicate that particular object also. Okay, so these are the the nature of the existence of your object. Thus already know about all these things in your object-oriented programming concept itself. Now coming to the very important thing. Okay, so how when you take up any data model, first we have to define what are the methods which will be supported to develop your model, and followed by after the development how to develop your schema. That is very important. Yes or no? So the schema is nothing but how your metadata, okay, so how your metadata is presented and how your structure will be, how your database structure will be. So that can be represented by your definition language. So the definition language is nothing but it is going to define your schema, not going to perform any manipulation there. Okay, so that is what here it is written. It is going to define your schema or create your schema. Is create your schema, and it is a schema definition, and it is not used for your manipulation. Okay. And now for representing your object definition language, we do have some template classes. Okay, so the template classes for defining object-oriented model. Now the dereference and classes used to specify your reference class. Say for example, if you are defining the entity, more than one entity, yes or no, and how your entities are connected. Okay, so in what reference, what is the association among this entity? All these things we will discuss. All these things we will discuss. Okay. So these are the template classes. By using this template classes only, that is dereference, and here you have to specify which class you want to refer and how many set of references you have from one class to another class. All these things can be precedes with a keyword is called as a dset as well as dereference. Okay, and if you have dbag as well as d-long integer, that will represent a duplication of, you are allowing the duplication. The certain column values may allow the duplicate value also. Okay, so this tool, this dereference as well as the dset, it is going to represent how one entity can be associated with another entity, that is represented by the keyword dereference as well as dset. So that we will discuss with an example. You'll understand better. So for this schema, ER banking system, we do have branch, customers, employee, as well as transactions. So for ER banking, so the ER banking system, so this already you done it in your relational model, relational database model. So every relational database model, we do have the entity as well as associated attribute also. And now, and every entity have a relationship. That is what I said in previously. For representing the relationship between your entities, we are having the dereference as well as the set of references also, that I will show you how to write the DDL commands. Yes. So now the branch have the certain association with the employee, and also the customer has a certain association with the branch, because the branch have more than one customer. Yes or no? So 1:n or n:1 kind of relationship we do have between the branch and the customer. And similar way, we do have some relationship between the employee as well as the branch. Okay. So how you are going to develop this entity and the attribute and the associated relationship, that can be by using the ODL commands. Yes. Look at this. This is very important in your definition language. When you take up any data model, so your data model must be built. Okay, so the data model must be built with the definition language as well as your DML commands. So the definition language in the sense what, especially for representing your schema. How many attributes are there? What is your entity name? And what is the relationship between one entity to another entity? All this, that is data definition, defining your schema. Only the definition, no operation. That is called as a data definition language. So here we are going to define the entity. Inside the entity, how many attributes are there, and each and every methods, how many methods are there in your entity, and also what is the relationship between the one entity to the other entity, that we are going to describe in terms of object-oriented database model, that we are calling this as a ODL. This is also called as a ODL. Okay, so this commands is also called as a ODL. Now, see here, we are creating the first entity, or we are creating the first class. Okay, so inside this first class is called as a branch, and inside the class we are using some of the persistent object, D object. Okay, so the D object is nothing but it is a persistent object from your root node or from your root entity. It will describe all the property, and that property can be accessed by all the entities, okay, all the sub entities or all the subclasses present in your hierarchy. Okay, so that is called as a D object or the persistent object. So if you are deriving this D object publicly, the meaning is your root node. Okay, so your root node properties can be publicly inherited with your branch class. Okay. So here your root entity or your root class is called as a person class. Okay, so from this the persistent object, it is called as a D object. So now, so the persistent object is publicly inherited with your branch. Now here also we do have the data member under the branch class. The data member we used to call it as a branch name as well as address and access. And these are the literals present in your ODL commands. So the literals is nothing but all are string type. Branch name is a string type, address is a string type, and access is the long. Okay. So here all must be precedes with D underscore that particular data type. Okay. So the D represent, it is a database. So the D represent D underscore string. These are called as a ODL literals. Okay. Now, once the definition of class branch is done and close the class branch similar way, you have to define the second class is called as account. This is also inherited from your root persistent object, D object. So now from this, here also this account class also some private data member. Private data member in the sense, this particular private attribute can be used only within the class. None of the other function cannot access this particular data. And similar way, under public data member also, here we have some public method. So the public data member is called as account number is one of the public data member. And also we do have some methods is there. Find the balance and also update the balance. These two are the methods present in your account. Here, the very important thing is, yeah. So the very important thing is, this is what we have to concentrate it. That is, here we are specifying the association among your object or association among your entities or association among your class. All terminologies are same. Understood? That means how employee works for department. Yes or no? How employee involved in a particular project. So we should represent, we should define the relationship between your object. We should define the relationship between your entity that has to be done in your DDL commands itself. I already told, for representing your relationship, we have to specify the keyword is called as a dereference. Okay, so the dereference here, your account is going to, yes, so here account is going to refer with your customer. Yes or no? So the account is going to refer with your customer and you specify the relationship name is called as a owners. So why we are specifying the D set? The D set is a M number of customers. The meaning is set of customers. You understood all of you? Once again, I'll repeat. See, this particular line is used for giving the association among your entities or relationship among your entities that is represented by this line. So how it is represented? Surely the account should be held by the customer. So should need a relationship between your account as well as customer. That is what we are making the relationship between the customer as well as this particular account. So that can be represented, that relationship name we defined as a owner. It is a user defined name. Any name want you can give it. See, in the UR model, in the relational model, you given us a works on relationship between the employee and the department. Works for relationship between the employee and the project. Is or no? So this works on and works for is a user defined name, relational name you given, relation name you given. And same way, here also we given some relation name is called as a owners. Okay, so this is only one line you have to focus on. The remaining all thing is simply for defining the data member and member function. So the extra one thing we are doing it only this line alone. That is, we are making the association among relationship among the customer as well as your account. So many number of the account should have more than one customer can have account, yes or no? So that can be set of, you have to specify the set of relationship. So that these set represent more than one, m number of customers. Okay, so the same way the remaining classes also represented. Here we are not specifying any relationship in the person class, and only we do have only two attribute name. And come to here. Here also we do have some relational representations or association or relational mapping. See, for example, inside the customer. So the customer is derived from the person class, and here also we have a data member or attribute is called as a member form, and also customer ID. And the very important thing is here we are having two association between the branch and the customer. Where is the branch? Here is the branch and the customer. So, and also the association between account and the customer is a vice versa. Yes, account and the customer and account. So the set of customers. Okay, so the set of customers can be represented by the D set, more than one m number of associations. 1:n or 1:m relationship can be represented by using the D reference as well as D set specification, and these two are representing as a relationship name. It is a user defined name for making a relationship between the branch and customer. And this is a relationship name, not relation name. Relation name is different, relationship name is different. Okay, so here the relation name is called customer, relationship is called account. These two are different totally. So the account is nothing but relationship name. So the account is related with your customer. Okay, so this specify the relationship also. So hope you understood the DDL commands in ODMG. So the DDL commands in the sense what you are going to define. You are going to define the schema. What we have defined here, we have defined the data. What are the data we have in your class or inside the entity, and what are the member method we have. So many methods we have. Yes or no? These are all the methods. Balance for finding the updates, the balance. These are the methods we have, and also followed by the very important thing is you have to define the relationship between the one entity to other entity. So these are the three different things you have to define in ODMG, ODL. ODMG, ODL in the sense object definition, object-oriented database manipulation language under what's it? Manipulation group. Under that, ODL is object definition language. We define all three. So once you define all these things, what is the next thing? The very important thing is a manipulation. Once your schema is ready, now your schema is ready for accepting any kind of data, performing some transaction, inserting some data into your table. Okay, so inserting data into your table, updating that values, deleting the values. Okay, so your database is now ready for your transaction. So that is what it is called as a data manipulation language. So in this data manipulation language, if you want to perform any operation on the database, of course, this particular database is based on your object-oriented data model paradigm. Yes or no? So with the support of object only, you can able to perform any kind of manipulation. Right? So that we are going to create object for this. Okay. So we are going to create the object of your bank database. So say for example here inside the what's it? Here you have the account entity. In this account entity, we are going to create an object. So how you are going to create an object? By using the new operator, you have to allocate some space in your database table. Okay, so using this new operator allocates data spaces in your table, not in the memory. Okay, database table, you have to allocate some space, and now using this account is an object now. Account is an object for your account class. Okay, so using this object, you can able to perform some manipulation on your account entity. So this is a general definitions I given here. Yes, and apart from that, some of other OML functions also. And say, for example, if you have an open database, so you specify the keyword open, automatically it will open the database and specify the database name. And you have to specify the object as like normal relational databases. You can able to do all the operation, but some syntactical difference will be there. But here, all these manipulations will be done with the support of object. Yes or no? That is what it is called as an object-oriented data model. Now you have to specify the data object, set the name of the object name. Okay, so object name you have to set up, and you have to look up the object name. So for referring the object name, you have to go for the lookup and renaming the object also. So you have to rename the object name and specify the old name, and followed by you have to specify the new name. And followed by once the transaction is done, you have to commit the transaction and close the transaction. So these are the some syntaxes you can easily refer in the book also. Okay. So already we know that all these properties of this D object only be inherited to all the other classes. Yes. Now coming to some of the manipulation commands here. So the commands is nothing but here we done the very important things, creating. Okay, so how we are going to create a particular table and how you are going to insert the records into the table by using the object-oriented paradigm. So since it is object-oriented paradigm, all your object-oriented concepts as well as database concepts together you have to write as a method. Okay, together you will write as a method, not like a normal SQL commands. Okay, so here inside the object-oriented method, you are going to invoke all the database transactions operations also. Okay, so you are creating a method. The first you are creating the method. Yeah. So creating the method here, the user defined method name given here, it is called as a create account. Okay, so it is the user defined name, and inside the create account method, we do have two parameters. It's called as a name as well as the address. And now we are creating the object for your database. Okay, so the database, the object name is called as a bank database dot object. Now for this object, the reference we are storing in another one pointer variable. That pointer variable is called as a bank underscore DB. So now when you use the bank underscore DB tends to open, the reference operator tends to open automatically, you have to specify your database name. Here your database name is called as a bank hyphen DB, your own name, your own created database, you have to specify your database name. Now you're going to begin the transaction by representing the object is called as a trans. So by using this object trans.begin, automatically the transaction will begin. So now what transaction we are going to do it? Create. Okay, so we are going to create a table and we are going to insert an object into it. Here the table is nothing but entity. Incomes entity is also called as a class name. Yes or no? So I hope you understood, able to correlate the concept of your object-oriented paradigm as well as ER diagram. Yes or no? So inside the normal method, we are going to done all your database transaction process. Now your plan is, yeah. So now your plan is you're going to create an object of your account entity as well as customer entity. Okay. So follow the same syntax. Your in proceeds with the reference and your class name is the account or entity name is the account. And by using the new operator, okay, so by using the new operator, you create an object for your account class. So your object name is account here. And similar way, using this dereference, you have to create an object, your object for your customer class. Your object name is customer. CUST. There's a user defined name, any name you can give it. And this is also specifying, this is a syntax as such you have to follow. Okay, so this is representing, again it is followed by class name only. Now in your hand you have an object, it is ready to access the content of account class, and the customer object, it is ready to access the content of customer class. Now what will you do? Now you have the schema design is there. In your hand, empty schema definition is there. Now you are going to insert some values into your schema. Yes or no? You have a you are planning to insert the values of a customer as well as account number by using the commands. Now, using the customer object, using the customer object. What is a customer object? CUST. So using the customer object and the dereference operator, now you are going to assign the value name. Okay, so assign the value of name and assign the value of address. Okay, now whatever values you taken up from the user name as well as address, that is going to insert. Okay, so that is going to insert by using this accounts. Okay, so using this customer object, you have to take up all the values. Now by using this accounts, you are going to insert the elements in your account table. Okay, so likewise you can do all the insertion process. Okay, you can all the insertion process, all the table of values can be filled up by taking up the value from the user, and that can be inserted back to the respective columns or respective entity. And once all the entity values are taken up and inserted into the table back, once all the process, that is what it is repeated again. And once all the process is done, you commit your transaction. Hope you know the commit process. Once your commit is done, automatically, permanently, your database transactions are saved. Okay? So once your database transactions are permanently saved, now by using this database object, the database object is a bank_db. By using this bank object, you have to close your database. Okay. Hope you understood. That means for the first DDL, ODL, what we have done in this ODL, we have defined all the schema. So the defined all the schema is we return the attribute, and we return the method, and also we define the relation. Okay, so these are the things we done in the ODL. In OML, what we have done in the OML, once the schema definition is done, structure is in your hand right now. So after the structure definition is over, now you have to insert the values. Okay, the associated values you have to insert into it, and you have to manipulate it, and you have to update the value, set the value, and delete the values. All these manipulations you have to do by using the OML commands, that is called as a object manipulation commands. So this is sample we done by using the create. Yes. And the same way, we do have some iterator also. So I'm not exceeding time. So see, actually, while you are presenting for exam, till that is fine. If you are completing till this is fine for giving answers for your exam point of view. Okay. So the exam point of view is what? Like we have to be asked you to explain the object-oriented data model. So you have to explain what is object-oriented paradiagram and how all the object-oriented paradiagrams are associated with respect to ER model, and how all the terminologies are correlated with the ER model. All things you try to explain with the proper diagrams, and followed by and how you represent the class. Write that, how to represent the class and how to define the object into that. Again, all the syntaxes and all, you define it. Okay, so all the class representations, object representation, you define it. And followed by every object model, you have a schema design that is called as a ODL. So how do you write the ODL commands? Okay, so the ODL commands is nothing but schema definition. Okay, so that's what we've done it now. So schema definition is define the attribute and define the method and define only the relationship, associations. We are not manipulating anything. So explain the ODL commands with some method. Okay, so that's what all we define. And now explain the OML. OML is nothing but object definition language. Is object definition language. So in this object definition object manipulation language. So in the object manipulation language is nothing but you can perform all the operation. So you can have your own things like create a database and insert all the values into it, delete the values, update the values, set the values, all these things. Some sample you can give it here. Till that it is fine. Okay, so fine for giving exam point of view, this answer is sufficient for you. But apart from that, for the knowledge about your object-oriented database, we should need to know about iterators also. Okay, so it is an optional one. If you want to write it in an exam, well and good. Otherwise, also not an issue at all. Okay, so till the manipulation commands, you stop. Okay, now iterator is nothing but if you want to extend your properties. Okay, so to the whole class. Okay, whole class. Say for example, if you want to print all the customer detail one by one, like a while statement, like a iterator, I can able to print it. Okay, so this is what I given here. The same thing we done it here. See, look here, all the created where database object. So inside one method print customer. Okay, inside one method we created the object database, the object for your database, and also for that object you made the references, and by using these references you open the database. Now begin your transaction. So in this transaction, what you are doing here, you have to extend your iterator to all the customers. Okay, so how you are extending it, that all the syntaxes are given here. Okay, so the syntaxes and all given here, how you specify the extend. Okay, so how you extend the properties, and also with the support of iterator, how you can able to access all the records present in your customer entity. Right, so define your iterator and define your extend. Now by using the while loop, you can able to print the customer detail like normal. Next pointer, automatically it will point to the next customer. Likewise, see, for example, in your relational model, if you are designing an API, okay, so designing an API, when you click the next record, automatically it will go to the next record. Is or no? The same way, if you want to fetch the details of the customer sequentially one by one, we have to go for the iterator till the end. So by using the while statement, we can able to print all the customer detail. And so this is also one of the sample example. Okay, transaction. Once the transaction is done, we have to commit the transaction and close your database. Okay, so this is your optional one. If you want, you can refer it. Okay, so for referring the continuous details of all your customers, so that you have to follow these two syntaxes first, and you have to apply this extend and iterator here. Now apply your while statement and print all the customer details. Yes, and another one thing is, okay, another one is sample thing. So like in the manipulation language, another after creation, the very important thing is select only. Yes or no? So the select only. So by using the select queries, okay, so by using the select queries, how you are going to retrieve the data from your database table, in your object-oriented database table, how you are going to retrieve the data, so that all the things we can take one example here. Then we can wind up. Okay, so here specify again this select query. We are going to run it up, and in there the result of your select query we are going to store in your temporary variable is called as a result. So what we have done, so that is also we have to specify here itself. Okay, specified here itself. Now this OQL, the OQL query, this is a query Q1, this is a name you given as like a normal thing, like how many how many number of accounts this particular zone customer is having, and find out the account which is having the balances greater than 100, which is having the balances greater than 100, right? So this query is very easily, normally relational data model, how we will write the same thing. Select select from, if you want to use it as a customer directly, you can use it customer, otherwise you can use it as a C. C is instead of calling the customer, you can use a variable C. So C dot account, fetch the account. In this fetch, whoever name is John, whose account is John, and how many account this John is having, and find the balance of the account, which account is having greater than 100 rupees, and that account you have to fetch it up and store in the variable is called as a result. Okay, so this is also one of your manipulation commands. Okay, so till that is very enough to write about your object-oriented data model. Okay. And now this is also, I already told, the same way object definition as well as object manipulation, you can able to implement in terms of interface also. Instead of class, you can go for the interface and you can define it. The same way how you done in your Java. The same thing. Instead of class, we define the interface here. Here it is no need to write in an exam. This is for your option. I am saying it. Okay. Yes. So the same thing, same ODL as well as OML, we can implement in your, instead of class, we can implement by using the interface. Yes, thank you for your kind cooperation. So any doubt, please make a